Right, swiftly moving on to our next speaker, I'd like to call on stage the CEO of Signi Energy Private Limited, Mr. Venkat Rajaraman on stage, please. Please give it to Mr. Venkat Rajaraman.
Good afternoon, everyone. After Raunak's sort of presentation, I looks like sort of an odd man out here. I am supposed to be talking about the IoT here, and let me just give you a brief background about myself and about what we do at Signi, just to get the sort of context in place. And then most of what I'm going to talk about is from a practitioner's perspective. Okay, all the things that I've learned on IoT is what not to do. What to do, I'm sure there are a lot of folks here who understand. We have learned the hard way in terms of what are all the things that not to be done. Very brief background about myself. So essentially I am a semiconductor guy. Used to work on semiconductor when it was not even called as IoT then. Then for a brief period of time, I was running a solar and inverter company called SUCAM 1, and then Signi Energy is, it's about 3 years old. So Signi is not so much on an IoT space, but we do have a product where there are a lot of IoTs which are enabled there. Very brief about Signi. Signi is essentially, we work on what is called as renewable energy plus energy efficiency. So we combine, solar and energy efficiency through DC appliances in one. We are an incubator of IIT Madras. This started about a little over 3 years back. What we have in the product today is, we have two things. One, we have, incorporated near field communication through a Bluetooth on the product. That was a learning. And then also we have incorporated GSM GPRS for monitoring purpose. Most of the talk that I'm going to talk about is just not about what we have done at Signi, but also some of the product that what we have done at SUCAM and other places actually. I'm going to start out with an example of what not to do in an IoT. So this is a product that we built. So this is essentially what is called as a energy monitor product. There are several of them available in the market. I don't know if you have, so this is essentially like, you put it in your plug socket, and then it connects to the Wi-Fi, and it sort of tells you how much is the power which is drawn from your refrigerator or from your air conditioner or whatever. It's essentially an energy monitoring device. And device is exactly how it looks like there. So we built this device for about 500 rupees, 500 to 600 rupees. We thought that this is something that was neat because energy was a black box for a very long time, and we thought that it's sort of going to help customers to sort of understand their energy usage. How many of you think that it's a good product? Oh, fantastic. I'm so happy to. This was a disaster of a product for us. Okay. And hard learning. The hard learning was that, if you are going to be selling for India, I'm going to be talking most of that India specific, people are value conscious everywhere. India is a lot more value conscious. Okay, so if you are going to give a product which is going to give them saying that, hey, your refrigerator is consuming 500 watts of power, nobody gives a damn about it. In the sense that there are very few. This is not the target audience for me for this product. I'm sure there are a lot of experts out here. But fundamentally, what happens is the value that the product can create. And the second learning was that, it's like, your Fitbit generation, right? In the sense that, just monitoring alone does not cut it. What is the actionable analytics that is going to happen out of it, right? What is that you're going to sort of give back in terms of value? See, if you're sort of going to be, monitoring your, your sort of, exercise control, for example, for a bit, actionable analytics is what is the diet that is going to sort of do that. Similarly, if you are, sort of going to be monitoring your sleep pattern, that's going to sort of determine in terms of whether you're going to take on a critical task next day or not, right? Lot of things basically depends in terms of both monitoring and a control in a way, okay? So this is something that we launched in the market and then could not sort of take it forward. The second thing is there is a need for IoT everywhere. IoT has become a cliched word now. Everybody, you talk about healthcare, you talk about ERP, you talk about infrastructure, you talk about energy. every time, I hear saying that, hey, listen, we can do an IoT there. My only sort of suggestion there is, before you sort of do anything on IoT, figure out whether, it's a need there. There are a lot of IoTs which we just go there and do it, but does not really have that desired value that, you might want to have from your customers, because IoT is going to cost you money. IoT is going to cost you a lot of time, effort, energy, and so on. Please make sure that, you really have a value proposition in terms of what is being done there. And of course, the segments are, very wide. I'm not going to preach to the choir here, but I think, clearly we see a lot of action on the energy space, whether it is electric vehicle, whether it is for home automation, whether it is for smart grid, whether it is for building management system. There is a whole plethora of, opportunities that are out there. I'll talk about some of them, in the subsequent slides. And of course, it is also existing in very many other verticals as well, actually. Correct. And of course, the industry has been doing very well. The last about a quarter on quarter, I think it's almost about $600 million of investment on an average is coming into the startups which are into the IoT space. But I think the most important thing is, several of us until about maybe year back or so, we were talking about basically you take an hardware, you plop it on, and then provide a software as a service, and then make the software sort of look sort of good, and then hardware aesthetically pleasing, and we were giving it to the customer. I think that paradigm is changing now. Clearly now, what's happening is, the hardware nobody wants to even know. I think it's behind the screen enabler. Don't even talk about it, because that is something that's sort of, you really do not sort of harp on. And number two is, I think, it's simply the pricing is determined by, the value that you're bringing to the customer. You say that, hey, listen, this is otherwise, you would end up spending for not having this, and I'm charging you a fraction of that for doing this. So, and of course, the focus is, the hardware goes free. Clearly, you're not sort of going to say that I'm going to have this, and then this is an odd-on value in terms of the costing for that. In terms of architectures and layers, of course, we talked about the edge computing very recently, and then you also have a lot of data processing platforms through the platform as a service model, and then you have apps built on top of that. I'm going to go quickly fast here because this is something, and of course, hardware, there are several of them which are available. Whether it is microchip or the good old Arduino or the Galileo, any one of them, every one of them give you the reference design, architecture, and pretty much whatever that is required to make it happen. But I think the point is, I think this is going to be, all of this selection finally is going to be based on the value in terms of the ultimate product that you are going to be selling in the market, and the value that the customer is going to be deriving out of it. And of course, on the cloud platforms, you have several options, with Amazon and Google, sort of ruling the roost there. And it's also important that, you sort of make your, platform scalable. You are going to have, the GDPR that has come in force recently. You're going to have very many of this security and protection which is going to happen. Make sure that your, cloud platform is scalable. And then, of course, make sure that the big data, the data which is getting, accumulated is humongous, and it's only going to increase. How do you sort of make anything meaningful out of the data that you are getting is also a very critical piece of puzzle that needs to be solved. I'm going to talk about one experience here. So this is the product that we brought to the market about maybe a year and a half or so back. Initially, what we had done was we had built the product with a near field communication. So we built that with a Bluetooth. We had a mobile app, and we said that, listen, anybody who wants to sort of know your energy consumption, go near the product, download the data. You will have the data for the last 3 months, 6 months, and so on and so forth. Then we realized saying that, and the product that I am basically catering to is all in the rural segments. These are all places where, the grid hasn't reached, or there are, sort of a peri-urban where, reaching these customers are very difficult, then I realized saying that for me to send a service engineer to these places and for them to download is a lot more expensive than having something else built on, So that was, so which means that, what architecture that you are using and who is your end customer are super critical, and I don't think there is a single solution that can sort of, match that. Then what we did was we, of course, added, GSM GPRS. What we realized was in India, rural India, close to about 60 million people don't have electricity, but all of them have mobile phones. Actually, it is, then we realized saying the cost of data for us is very cheap. Today, we are getting this 20 megabyte per second a SIM card at 8 rupees per month. We are paying about 96 rupees per annum, and we are taking almost about 6,000 of these SIM cards on a monthly basis. So which means that we have installed so far about 30,000 of these systems all over. The value that now we are deriving is far more than this 100 rupees plus the cost of hardware that you are giving, because for me to send a service engineer to this place is in excess of 500, 600 rupees I need to spend him on a day basis actually. So this was one of the learning, and the other thing is, I don't know if you can see it, we built with the bunch of smart guys from IIT, we built this mobile app, and the first version of the mobile app looks exactly what I'm showing you here. I don't know whether it looks cool or not, but I tell you this has data about current and power and watts and watt hours and so on. Nobody understands. Your customer does not understand any of them. This is one way of not to do a mobile app. So the guys, what they take, they believe that it's a beautiful way to present it with all the, graphs and so on and so forth. But I think what is most critical is, can you give, an actionable, simple viewpoint? All he needs to know is, hey, listen, your solar panel needs cleaning, right? All he needs to know is, hey, listen, your solar is underutilized, right? And, so these are all some very simple ways, but sometimes what happens is, engineers build the product, you have a problem actually, so that's, I'm sure, hall is filled with engineers, but this is something that, a hard-earned lesson, what we had. Now, of course, we have changed the, our mobile app looks much better now. And then, of course, on the you have this, a platform, a web portal where a lot more data analytics gets done. Again, here, choosing the right sort of architecture is super critical, in the sense that when we started building it, we thought saying that, hey, listen, we are going to do for about, 1,000 systems. How do we build it? Then we started showing all the 1,000 systems on the left-hand side so that somebody can search and pick it. What happens when that becomes 30,000 systems? Okay, what happens when you are geographically distributed? You have something going on in Manipur, something in Rajasthan. So I think it's very important to make sure that you spend a lot more time on building this architecture right from ground up. You don't have to build all of them on day one, but make sure that you build still that MVP in terms of what is required. But make sure that your architecture has all the hooks and this thing to make sure that tomorrow, if you want to scale, the architecture is easily scalable. Otherwise, what happens, many a times I have seen, they start with something and after 6 months, they end up making some changes. About a year later, they end up making some more changes. And 2 years later, the system is unusable actually, because of, I think it's very important to spend that time to make sure that we get this right. And of course, when we did it, we realized saying that, the backend platform application just does not, it's not a standalone application in very many cases. You want to make sure this integrates with the building management system. This integrates with, maybe an EV charging software. So you need to make sure that your system is easily sort of integratable with other, sort of applications which are out there. And that's also a key piece of the puzzle, because all of them will have to sort of at some point of time, sort of converge and come together actually. Yeah, so the data analytics part of it, so clearly I think, this is something where, 3 clicks or less, as they call it, right? And actionable analytics. These two are critical. However much of processing that you may do it on the back end, as far as the customer is concerned, I think he needs to get, what they call it as a, grandma approved kind of, your decision points actually. Yeah, talking about, so when we started this, the product that what we have is basically monitors the energy. You can understand, it sort of monitors how much of solar power is getting generated, how much is going into the battery, coming out, and what is the load, and so on. We were, just to give you an example, we were capturing about 25 data points for every half an hour. So which means that, during the daytime, we had every half an hour. During the night time, we were capturing every hour. What we realized was, we have about 625 data points on a yearly, on a daily basis. And then what happens is, if you sort of extrapolate, you're talking about 200,000 data points. We had at that point of time about 25,000 of these installations. Now you look at it, this data point quickly sort of becomes about a 5 billion data points. For data points in the sense that your data in our case could be 32 byte of data. 32 byte of data at about 5 billion, you're talking about almost close to a terabyte of data. And what happens if I go from 25,000 systems to a 250,000 system? You have truly a data explosion, actually. So which means that, it's very important to make sure that you make meaning out of the data very quickly and don't allow your data to explode, actually. So this is something that, I think all of us are sort of going to face this at some point of time. Very quickly on the next two slides on energy, and then I will let that go. Energy is something which is close to my heart. What's happening is, you are now, as an IoT, you have there is an EnerNet, there is an energy of things, and clearly the energy is undergoing, rapid paradigm shift in terms of how the energy is generated, how the energy is consumed. And you're also seeing for very many places that there is a leapfrogging of energy is happening. 10 years back, India sort of had this leapfrogging in terms of the, communication. A lot of, homes which did not have the landline went directly from no communication to a mobile. And in energy, same thing is happening. Lot of homes which does not, do not have this, grid power. Now they are going into a completely, off-grid based power, and they are completely standalone. You are seeing that for, just not in India, but very many places of South Asia and Africa. And the other thing what's also happening is democratization of energy. There are going to be, today if you want for your home or office, you have only one utility provider. You do not even have an option if he's going to sort of escalate your power bill by 8-10%. You do not have an option. That also is going to change. And all of them are going to change with the distributed energy generation coupled with the Internet of Things and the digital finance, where you are going to do a mobile payment and so on for your energy. And that is going to be the sort of way, which means that as I see it, there is a tremendous opportunity on all of these spaces for many of the young entrepreneurs to sort of come there. Yeah, this is the day. I'll skip this slide. So, designing the hardware, I think Raunak talked about it beautifully last slide. So, I think the only 2 points I have is, pick your hardware well, spend time, pick your hardware well, and not only that, make sure that the hardware is scalable. If you're providing a footprint for a 16-bit microcontroller, make sure that the same footprint can work for a 32-bit, right? Similarly, if you have, a 32 megabyte of memory, flash RAM inside your hardware, make sure that it's scalable so that you don't have to, rehash your hardware there. And number 2 is when you are sort of working on your firmware platform, again, look at, what kind of, embedded OS you are going to use, and in terms of, how are you going to sort of handle this security issues of data, how you are going to make, if your system is going to be, over the air compatible in terms of firmware upgrade, pretty much, look at all of them, because these are all easier said than done, and these are all very specific. So, the one that I could tell you is that, when we were going through this earlier, we had to do this hardware rehashing almost every year or so, which I think could have been very well avoided if you had spent enough time on, sort of on the design phase. This is another application of, same IoT. What's happening is today, if you have a rooftop solar power and if your neighbor also has a power, there is a technology which allows you to sort of share the power. Somebody can sell your excess power and somebody needs, additional power, he can buy it from you. This, is essentially a blockchain in terms of energy transfer. If somebody is interested to see this demo, we are, sort of exhibiting in the Indian Green Building Congress in Hyderabad starting next week, and same thing is happening also in Climate Jamboree in the Terry in Delhi as well, actually. So I think this is the last slide, and then I'll. There are two things that's happening on the IoT side from an energy perspective. One, there is a change in which the utilities are currently. The utility as it exists today is going to be dead. Okay, and the five things that are going to be very critical is the energy is going to be a decentralized energy. So you're going to be generating closer to your home and offices where you are consuming it. And it is going to be a decarbonized energy. You are going to be relying on renewable energy for your local consumption, and this energy is going to be digitized in the sense that the same way that I can buy for 20 rupees some 10 megabyte of data on your mobile phone, you should be able to sort of buy 2 units of power for 20 rupees on your same platform as well. And energy is going to be democratized as well. We talked about in the previous slide, we should be able to sort of generate energy on the roof of this building, and then if you have an excess power, you should be able to sort of sell it. And of course, this is going to go through a lot of disruption. We believe that I think the time has come for a sort of where the digitized energy is going to play a huge role in terms of how the energy is is sort of generated and consumed. And also, if you look at it, energy as a platform. I remember when we used to do a inverter at SUCAM, the moment you buy an inverter, it is going to be sort of put in a place where nobody gets to even see it actually. Okay. That and all is gone. If you look at, for example, a Tesla Powerwall, today you buy a Powerwall, you want to put it right next to your television. You want to sort of show it off. And that is also changing. The same thing is happening on the energy industry. The product design aesthetics is going to be very critical actually. That's pretty much all I had in terms of what I had to talk about. If there are any questions, I'll be more than happy to take it up. Yeah, please.
The energy industry, because of its nature, where only one coal plant or a gas-based plant will generate power, and we will all consume. Now it's become distributed. How is the regulatory framework? Because it is a highly regulated industry, naturally, because up to now there was no storage.
Right.
So demand and supply has to be managed second to second. I mean, it's the marvel of our civilization.
Right.
People probably don't realize
Right.
what a marvel it is. How is the government rules and regulation supporting this?
Right. Yeah, fantastic question. I think, the short answer is I think they are doing a catching up game. For example, when Ather launched electric vehicles recently in Bangalore, if you go to a shopping mall and if you want to charge your electric vehicle, who pays for it and who gets the money? Today, the regulation does not allow a private player to go and sell your power to, a third party actually, okay? But the amazing thing that had happened is the last 1 month, the Electricity Act itself has gotten sort of amended to include some of these changes. So, the answer is in short, one, I think, regulatory has to play a big role, no doubt about it. Number two, that's also happening is, for example, I think he brought out a fantastic point. So today, for example, India's renewable penetration is very small, less than 10% actually. Now, what happens if the renewable penetration is 50%? What is going to happen? Suddenly there is a cloud on the sky and then your entire generation sort of drops down. How is it going to be handled? Big challenges. I think there are, there are examples how it can be done, but I am sure, we would also sort of, have the right technologies to handle that as well, actually. Yeah.
I've seen a lot of things happening in IIT Madras. Can you give a brief update on? Because I've seen a lot of products.
Okay. Yeah, I'm on the other side of the table for IIT Madras. But what I've seen was two things. One, I don't know how many of you have gone to the IIT Madras Research Park, which is in Tharamani, which is right next to the the Ramanujan IT campus. What IIT Madras did was two things. One, I think they built this fantastic sort of making sure that the academia, industry, and the young grads can sort of combine together in one ecosystem. That is one. And number two was, of course, typically what happens was, a sort of a professor takes a lead role. Unlike US, what happens is in India, there is a whole bunch of problems which are there for if you are an academician, if you want to start your own company, it's absolutely not easy actually, right? I have a feeling that, of course, all credit goes to Professor Junjunwala for those of you who know him. I know he made sure that that all of those issues are addressed to a great extent. There are a lot of learning that I can talk about separately, of course, but I think it's a fantastic ecosystem that IIT Madras has created, and some of the companies that had come out are real examples of what could happen when fresh young engineers combine them with academicians and the industry. When they come together, magic can happen actually. Yeah.
And one point is that it's amazing in terms of the mid-level scalability, what extra can be done. That is one problem I've seen is that I'm an old man. I've seen so many things come up, nothing scales big.
From you're talking, yeah. So I think if I understand your question, scalability from an entrepreneurship viewpoint, in the sense that they do and then they don't take it up, Yeah, I think that's a tough problem. The only answer I have is the thing that comes to my mind is, I don't know how many of you have seen this Matt Damon movie. It's called Martian. Okay, the guy spends 3 years in Mars, and then finally the very last scene, he goes inside a classroom like this, and then he asks, how did you manage to spend 3 years there? He says that, listen, I get up in the morning, solve one problem. Once that's solved, I solve another problem, and then I solve the third one. I solve the fourth problem, and I'm tired. I go to bed actually. Okay, and he did it for 3 years. So ultimately, it's all about our perseverance. What I see is that a lot of good stuff happened, but that's the first level of real failure, right? People tend to give up. That could be my reason for that actually. Yeah.
All right, I'm going to request all other questions.
Okay. Thank you.